reply, and then now I can upload the lesson. So, chemistry. We want to straight away look at what is known as chemical bonding. So in chemistry O-level syllabus, there are only 3 types of bonds. What are they? Some might have learned this in engineer school. What are the 3 types of bonds, Nigel? Bonding.
The 3 types of bonds.
Yes, chemical bonds. We've got a symbol covalent. Okay. We have ionic bonding. We have metallic bonding. Then the 4th thing here is under this, it's called a giant covalent bond. Symbol covalent bonds, ionic, metallic, and giant covalent. So I want to start with metallic. What is a metallic? What is metallic bonding?
Metallic bond is caused by the attraction between negatively charged delocalized electrons and positively charged metallic.
Yeah, but you left is bonding. Where does it happen? What you're saying is true, but
metals.
yes. So number 1, first point. This is bonding in a metal. This is bonding in metals. Bonding in bonding in metals. Where we have a lattice structure. The diagram will give you a lattice structure of delocalized electrons. Delocalized electrons and positive ions. Positive ions.
Can you please read that line?
You see the structure of
Metallic bonding. We are saying this is bonding in metals where we have a lattice structure of delocalized because the electrons are outside the shell. Delocalized electrons and positive ions. So we've got a lattice structure. It's more like a 3D structure, if I can take it. That's why it's called a lattice structure. So it goes on like that. So these delocalized, they move between these positive ions, delocalized electrons. Yeah. Now, my good question here. Can a metal conduct electricity in liquid state?
Yes.
In solid state?
Yes.
Or gaseous state? Which states? Can it conduct electricity in any of these states?
I think it can conduct in liquid and in solid.
Okay. Because why? Because the delocalized electrons can freely move. So a metal can conduct electricity. Actually, in any state, clear. Because the delocalized electrons can freely move. Now, let's look at ionic now. What is an ionic bond? Ionic bonding What is ionic bonding? Ionic bonding. What is it? You've never heard about it. Ionic bonding is bonding between a metal. Be bonding between a metal and a non-metal. That's like form 2 definition. Now we continue. Where a metal loses electrons. In fact, sorry, this is the correct term here. Gives away electrons to form a positive ion and a non-metal accepts electrons to form a negative ion. Form a negative.
A negative.
Negative ion. Now, characteristics of an ionic bond. Number 1, strong force of attraction between positive and negative ions. Require very high energy to break. Therefore, so if it requires very high energy to break, what can you say about the boiling point and melting point? Therefore, you need high to break that. So therefore, ionic bonds have high boiling point. High boiling point. In brackets, you can write most metals have boiling point. BP means boiling point above 800 degrees Celsius. And the high melting point. And the high melting. Are we together?
Yes.
Ionic bonds. Second point, only conducts electricity in what state? Can it conduct electricity? Why not in solid? Yes, molten. Why or liquid? Why not in solid state? In molten.
Because particles have no room to move.
In molten state or liquid. Sorry, or aqueous state. Clear? The reason, because the positive and negative ions can freely move. Because the ions can freely move. The solid state.
I mean, please come again.
because the ions can freely move in molten state or aqueous state. Now, clear so far?
Yes, sir.
Now, if I write this in chemistry here, some of you are thinking, no, sodium chloride, your table salt. Then I write AQ. Then I write sodium chloride liquid, L. Can someone tell me what's the difference between aqueous and what's the difference between liquid? What's the difference between aqueous and liquid state? What's the difference? Andrew? What is the difference? Aqueous and liquid state. You think they're the same? They're different. Aqueous
So
means, yes. And sorry?
is the solution made by the solvent is water?
Aqueous simply means they're in water. Clear, dissolved in water. This simply means liquid state. You heat the metal, no water, so no water, but in liquid state. It's like if I take a solid here, so salt, and I continuously heat salt, and it's closed so that it will turn to a liquid, to your liquid salt, sodium chloride. That's what we call liquid state. It's not aqueous. Aqueous is when you dissolve it in water. Clear? So ionic bonds conduct electricity in liquid state and in aqueous. Making sense? Now let's do our chemistry
Yes, sir.
using our periodic table. Now let's look at different types of ionic bonds. We want to start with the sodium chloride that we talked about. So now if you go and check your sodium chloride in your periodic table, it's written 2311. Then your chlorine, which is group 7, if you go to group 7, it's written 35.5, then 70. Notice your periodic table might write it like this: 11, 23. It doesn't matter, or question mark. The mass number is always larger than the total number. Clear? So what it means is that this has got 11 electrons. And this has got 70 electrons. Because this is a metal and this is a non-metal. So it's ionic bonding. Then we think of the configuration. First shell maximum 2 electrons. Second shell maximum 8. Last shell maximum 8 again. If we do this, 2, 8. Then when we are drawing the shells, we can ignore this and we concentrate with the valence, with the last shell. Last shell has got 1 electron. Then we go to chlorine here. Chlorine, which has got 17, sorry, my apologies, 2, 8, 7, 17. So this has 7 electrons. So chlorine accepts metal, gives away electrons. So this gives away the 1 electron like this. And this now accepts, and remember it needs, if it's 8, it's complete. So the new configuration of this becomes 2, 8. Now an ion. Because it has given 1 electron, is now 1 less negative. It forms a positive ion like this. This chlorine is accepted. It has 1 more negative, so it forms a Cl minus. Is that making sense?
Yes, sir.
Okay. let's look at another example. We want to see what happens when sodium reacts with oxygen. Oxygen can only exist as a molecule in nature, like this. Now, go to your periodic table. We said this is 11, so it's 2, 8, 1. Can someone tell me, go to group 6, how many electrons does one oxygen have? How many electrons? Oxygen. Oxygen is like this, 16. We said the small one is the proton number. So it's 8, not 6. 16 is the mass. The smaller number is the proton number, which is equal to the number of electrons before it is. So it's 8. It gives you 2 what? 2 states. Remember, so the sodium metal. Then we draw the oxygen there. We are ignoring the. You can draw the shells inside. We are ignoring them for now. They are not necessary. We want to concentrate on what happens in the last step. So my question is that, look at this. We are giving away 1 electron. And it's obvious we are going to remain with 2, 8. Can we take electrons from the inner shells? We can't do that. We only take electrons from the outer shell. So what is going to happen here? We've got 7, 1 is missing. Where are we going to get the other one? Where are we going to get the other electrons to fill this? So that is 8. We draw another sodium. It's like another sodium reacts with the same oxygen. Like this. Making sense? So it means this 1 oxygen is accepted 2, is now 2 more negative. So it's like this. That's the ion. This single sodium is given 1 electron, so it's 1 electron less, like this. This 1 electron less. But that tells you that I have got 2 sodiums. I always start with the metal. So the formula of sodium oxide is N2O. That's where it comes from. Are we together? Are you guys there?
Yes, sir.
So now if you go to that same group 1 day, if you see there's lithium, there's sodium, there's potassium, because they are the same group, they've got 1 electron in the last shell. So it means they always form the same formula. If it's potassium oxide, is potassium oxide like this. Lithium oxide is lithium oxide because it's the same. The number of shells are different because if you look at, this has got 3 electrons here, so it's 2, 1. This has got 11, so it's 2, 8, 1. But this here is 2, 8, 8, 1. But same electron, that's why it's called group 1. Same number of electrons in the last cell. So therefore they react in a similar way because we are having 1 electron like this. So that's why we form the same formula. Making sense?
Yes, sir.
Let's try magnesium and oxygen and see the type of bonding: magnesium metal, oxygen non-metal. Now, how many electrons? Can you use your periodic tables? I want someone to tell me how many electrons are in magnesium. Moses, how many electrons are in magnesium using a periodic table? Moses, I've lost it. Joanna, how many
Yes, sir.
electrons? Yes, I wanted Moses to answer. Joanna, okay, Moses first. How many electrons are in magnesium? Just check your periodic table. I can help you if you're not sure. How many electrons are in magnesium? Check your periodic table. It's group 2. Groups are going down. Group 2. Do you have your periodic table or you don't have it with you? Emily and Esther, do you have a periodic table with you?
Yes, sir.
Okay. So how many, Esther, how many electrons are in magnesium? If you look at magnesium, it's group 2. There's group 1, then there's group 2. Magnesium, how many electrons?
Still looking for the periodic table.
Oh, okay.
Six. Six.
It should be like at your back of your textbook, or if you go to the topic that we are doing with bonding, you see a periodic table or electronic. But I think most of back of your textbooks. You said how many? Is that 12? Huh? Okay, so 12 electrons. So now, if it's 12, can someone give me the correct electronic configuration of magnesium? Joanna, what's the correct electronic configuration of magnesium? 2 what? First shell, always 2. Yes. 8,
2.
2. First shell is always 2. Second shell, 8. Third shell, 8. 2, 8, 2. That's why it's group 2 here. Now, oxygen, we talked about it, we said this 2, 6. Remember, it's a non-metal. This one is the one that is accepting electrons. Now we can ignore. Remember, you can draw the first shell, you put 2 electrons, you draw the third, but we are ignoring that. We are concentrating on the last shell. So now, magnesium, unless you're told to draw all the shells like that. Then your oxygen, which is got 6. So this gives 7, 8. This is perfect. So now if it's giving 2, it means it forms an Mg2+. 2 is giving away 2 electrons. This one is accepting 2 or 2 negative. But it's 1:1 in that we are reacting 1 magnesium with 1 that. So it means the formula of group 2 oxides are always like this. Barium oxide, calcium oxide. That's where it's coming from. Because calcium, in the same similar way, there's 2 electrons in the last cell. So it gives 2, oxygen accepts 2. Making sense? Is that true?
Yes.
Yes. So now let's work the tricky one, the one that they love in exams. Aluminium plus oxygen. Aluminium plus oxygen. We lost one of you. Now, can someone tell me, Nigel, how many electrons? The girls, did you find the periodic table? You were looking for the in your book. Periodic table.
Yes.
Okay. So now, how many aluminium is group 3? Go and check aluminium. How many electrons? Electrons, how many?
13.
13. Huh? So
13.
13, Moses, what's the electronic configuration? If it's 13, 2 what?
2, 8,
3.
3.
Now, oxygen, we said 2, 6. So now let's concentrate with the last shells. The inner shells don't really matter because they are not involved in a chemical reaction. In any chemical reaction, it's always the outer shells. So now we've got oxygen there. 6, 2, 4, 6. Aluminium 1, 2, 3. So we have this friend of ours giving that, this friend of ours giving that. The oxygen is complete, but we can't leave this like this because it's not stable. When you're doing ionic bonding, all the valence electrons is the number of electrons in the outer shell. They have to be used up. Then the non-metal receiving, the non-metal should also be complete. So this oxygen is now complete 8. So what do? We have got a challenge here. We have 1 here. We draw another one. Another oxygen.
Another shell.
Yes, another oxygen atom. Not really shell. Another oxygen atom. Clear. Now, then this guy gives here, we now have 7. We still need 1 more. But we have exhausted the 3. We draw another one. Aluminium. 1, 2, 3. Then this guy gives, is now complete. But the challenge, this is not balanced because we have 2 electrons in the last shell. We draw another what? Oxygen. I'm sure you see now that is going to sort itself. So we need 2, 1, 2. Making sense? This guy is given 3, Al, 3 plus iron. This guy is given 3 Al3 plus I. This is accepted 2, like what you said, accepted 2. I'm saying in terms of the ions there. How many aluminiums? We always start with the metal, 2 aluminiums. So that's why the formula is like this. How many oxygens? 3 of them. That's the formula, aluminium oxide. Heavy?
Yes.
Now, what I want you now, everyone, I'll give you 2 minutes, is to use ionic bonding concept to wake up the formula of lithium plus lithium nitrate. What would be the formula? Or you use your ionic bonding to check nitrogen, or the same way we're doing, then try to cross it because it's a metal and a non-metal. It should be done now. Moses.
I think I'm done.
So if you check lithium 2,1, nitrogen 2,5, huh? So this is a metal with a non-metal covalent. Nitrogen 5, 2, 4, 5. So this guy gives 1, so that is 6, so we can put it there, it doesn't matter. So I need 2 more. This one is actually easy. So now I draw another lithium. Then this guy gives 1 there. Then I have to draw another what? Lithium. We need 3 lithiums. Then like this. Then it's complete. So lithium giving 1, lithium positive, lithium plus. Nitrogen accepting 3 and 3, but it's 3 lithium, so it's L3 like this. Lithium, try lithium nitrate. Try for 3 lithium nitrate. Clear? Anyway, now, so we can now write what I wanted to write here. So we now know the formula. So it's C3 nitrogen. My next question is, how do we balance this? We have 3 here, we've got 1 nitrate, we've got 2 nitrogens. So if I put 2 here, I'll have 2 nitrogens and 2 nitrogens here. But now I have 6 lithiums. So I need 6 balanced equation. But today we're not talking about balancing of equations. Now let's look at covalent bonding. We'll start with symbol covalent bonding. Who can define symbol covalent bonding? So what I encourage you to do is, when we are doing these topics, you also go in the textbook after lessons and you go through some of the content so that you see the covalent bonding. What is it? Don't just rely on the lesson only.
So I think it's formed in non-metals only.
Okay. Bonding, first point correct. Bonding between atoms of a molecule of a non-metal. That's first condition of a non-metal, or between two non-metals. Between 2 non-metals. So an example of what I'm talking about here. If I have chlorine like this is a covalent bond between this is a molecule here. So the bonding between this chlorine and this chlorine is covalent. If I've got hydrogen H2 like this, the bonding between hydrogen and hydrogen is covalent. Then the second point that we're saying, between 2 non-metals, if I've got the hydrogen, right there. These are both non-metals, so it's covalent bonding. Clear? If I've got carbon dioxide, covalent bonding. Nitrogen like this, covalent bonding. So now the next point, what happens? They share what? Share edge electrons. So it's sharing. There's no one giving away and another one accepting. The concept sharing of paired electrons. Yeah. sharing of paired electrons between the bonds. So it's sharing, electron sharing. So let's look at Cl2 like this. We now know that chlorine is 287. So I'll draw chlorine here, the first chlorine. Then I'll put 7. I'll ignore the rest. Then I draw another chlorine like this. This one, I don't want to put it here. I'll put it between the bonds. So I've got the chlorine here. Now, when you're doing this, I can't put X again because you don't know, you won't be able to see the same. So I can use small circles or I can use dots like this to represent electrons from the other. So 2, 4. Then the 7th one is used for sharing. So one is coming from this, the other one is coming. So it's a single bond like this. That's why it's a single covalent bond. Clear? Are we together?
Yes, sir.
Okay. So
Yes, sir.
the other point that you now need to write here, besides what I've said here, is that in terms of the bonding here, weak. Okay. So we've got two types, huh? We've got bonds between, so we've got weak van der Waals forces of attraction. Weak forces of attraction between the shared bonded electrons, which require very low energy to break. So if they require, it means covalent bonds have got very low, very low boiling points, very low, don't need much energy, very low melting points. You find that most of your covalent bonds, the boiling point here is actually below 0 degrees, huh? For most of them. Clear? You can find some maybe 80, 40. So those are weak. Those are simple covalent bonds. Yeah.
Yes, sir.
Now, if we look at hydrogen, so I want to give you the ones that you always get in exam. Now, if we get hydrogen, which is very easy, hydrogen H2. Hydrogen can only have, it has got one shell. So we can't talk of 8. We're simply talking of 1 here. Okay. So hydrogen here, it's 1 from this, 1 from that. So with the hydrogen, you have something like this. Hydrogen, hydrogen. So it's complete 2 electrons, 2 electrons. Because you're having 1 electron from the hydrogen, 1 electron from the other hydrogen. Complete. The tricky ones now. Tricky covalent bonds. For your example, is carbon dioxide, is oxygen, and nitrogen. And they love you bringing those ones. Why? Because carbon dioxide is like this. So if you don't know this now, even the bonding, this is a double pair, this is a double pair. What it means is that the carbon is the central atom. Then I've got an oxygen from this side. Then I've got the oxygen. Then what it means by pair, double pair is like this. Then double pair this side like this. Clear? Now my question is, when we have done this, do we need to add any electron to the carbon, the central atom? Do we need to add anything? 1, 2, 3, 4, 5, 6, 7, 8, complete. You don't need, we need to add on this, we need to add on this. So what we can do now, we can, this is 4 this side, 6, 8. We do the same here, 4 this side, 6, 8. That's the correct bonding. For what? For carbon dioxide. Clear?
Yes.
Now, oxygen is also like this. So, the oxygen simply means double pair. So we've got 4 here, 6, 8. Then the dots are coming from this one here. That's the covalent bonding, an oxygen molecule. Then the last one, nitrogen. That's how it looks like. It needs very high energy because of, unlike, of course, not to compare to metals, but I'm saying unlike other covalent because it has got a triple bond. So now, triple bond. One pair, 2 pairs, nitrogen, nitrogen. So 6 here, 7, 8, 7, 8. Making sense?
Yes, sir.
So the last thing for the lesson, let's quickly have a table where we compare metals and non-metals in general, properties. What can it say comparing metals and non-metals in chemistry? And it formed yeah. Some of this we talked about. Yes, metals. What
I
states
think
do you find
metals-
metals in general? Are they solids, liquids, or gases at room temperature? Metals, solids, liquids, or gases?
Also solid temperature.
All metals except one. All metals, solids, all solids at room temperature. RTP means room temperature. Except what?
Mercury.
Except mercury. It's the only metal that is liquid at room temperature. Most gases at room temperature, but some are solid, are liquid at room temperature. Clear? Now, what else between that? Metals, they give you a shiny what? Shine surface in appearance. Huh? What else?
one is ductile.
Ductile. What does that mean?
I think it was being drawn into like sort of like wires. So
Drawn into wire, they can be stretched. They can be stretched. They can change into different shapes. Huh? They can form different shapes. Now you also have malleable, and these are non-malleable. What does sonorous mean? Sonorous?
I think I'm not sure, but I think it's probably ringing or something.
It means they make a sound when you hit them. Clear?
Yes.
Metals have high boiling points, right? High boiling points and melting points. low boiling point and melting point. Metals have got a high density. These ones have got low density. Metals are heavy. Clear? Metals form positive ions. Positive ions when they react. What do you call the name positive ions? When they react.
Stations.
We call that, yes, that's science. These ones form negative ions when they react. And we call that anion.
Anions.
Then metals conduct what? Electricity in any state. Non-metals don't conduct electricity. These ones are good conductors in general, good conductors of heat. And these ones, bad conductors of heat. Do we agree?
Yes, sir.
Any
Yes,
other that you can think of between the metal and the nanometers? So you have a chemist homework on bonding. Multiple choice. It shows you exactly how much you understand of this topic. Maybe do some reading. What's the next lesson, by the way? Today is what, Wednesday. There's another bio. Is that correct? On your timetable.
Math.
Maths first.
I mean from 2 it's math, and then now it's like lunchtime. So from 2 to 3 it's math, and then biology, then math exercise at 4.
Maths is first at 4. Okay, that's fine. So we'll see. You can go for lunch.
Thank you, sir.
Yeah.